our today's topic is soil salinity. The soils, they are also called as the halomorphic soils. Those soils which have higher concentrations of salts, they are called as the saline soils or halomorphic soils. In which areas these kinds of soils they are common? So this salinity, it is said to be the problem of arid regions, but it can also be observed in the semi-arid or humid and sub-humid regions as well. But usually this problem of salinity is related with the arid areas, the dry regions where there is less rainfall and the soil, it remains dry during most of the year. So we usually correlate this problem of salinity with the arid regions. Artificial irrigation results in addition of more salts to the soil than are leached down. For example, if you, as I have already said, that the salinity is the problem of arid regions. So in arid regions, if we want to grow the crops, we irrigate the fields ourselves. So when we irrigate the fields, and if that irrigation water, it contains salts, then it will further add to the salinity problem of that region. So we have to be very careful that whatever water we are using for irrigation, it should be free of salts. And if it contains the salt, then this water will result in adding more salts to the soils. So the more salt will be added to the soil as compared to what which is leached down by the water. Water की ये क्वालिटी है ना कि अपने अंदर salts को dissolve कर लेता है, और पानी जो है क्योंकि due to the force of gravity it moves downward towards the ground water, तो फिर वो अपने साथ इन डिजॉल्व सॉल्ट्स को भी ले जाता है नीचे डीपर लेयर्स में. लेकिन अगर सॉल्ट उस पानी के अंदर ही सॉल्ट्स मौजूद हैं, तो फिर ये जो है पानी, ये भी सैलिनिटी कॉज करने का बाइस बनेगा. These excessive salts, they accumulate in the surface layers of the soils as water is lost by evaporation. So ultimately the upper layers of the soil which are moist, the water from these upper layers, it will evaporate into the atmosphere. So the water vapors, they will escape from the surface of the soil while leaving the salt on the top soil, upper surface of the soil. So this will result in the salinity of the soil, and we know that usually the roots of the plants, they are more concentrated on the upper soil layer. So we will observe the salt in the root zone of the plant. So this will be a great problem for the growth of the plants. Evaporation of water from surface bring more water from subsoils by capillary movement. As the upper layers of the soils, they become dry, what happens naturally due to the force of capillarity, the moisture which is located deep in the deeper layers of the soil, it will come upward due to the capillary movement of water. When the water from the deeper layer, it moves upward towards the surface layers of the soil, the water will bring salts along with it, which was located in the deeper layers, towards the upper soil layers. So as a result, this water will bring more and more salt from the deeper layers to the surface layer of the soil. Water will evaporate, but it will leave behind the salts which were present in that water. So in this way, you see, there are many sources from which the salt is being added into the soil. One is if your irrigation water is salty, it is having salt concentration. Secondly, if the region is arid, region is dry, the capillary water which is moving upward, it will also bring salt from the deeper layers towards the surface layers. So in this way, the salt, it gets accumulated, it's get added up into the surface layers of the soil. So this will result ultimately in the rendering the soil saline or the halomorphic, or they will be having the higher concentrations of salts. So you see the continuous evaporation and upward movement of water by capillary action results in more accumulation of salts and soil become non-productive, or we can say the soil has become saline. So if the soil has become non-productive, it means that you are not able to cultivate any crop in that soil. You cannot grow any plant in that soil, because you see we have studied water potential. All the water of the plant, it will be lost through the roots, and the plant, it will become dehydrated. So the shrinkage of plasmolysis will take place, the shrinkage of protoplasm will take place, and ultimately the plant will die. The problem of salinity is more severe in areas with high water table. Those areas where the water table is high, more water is present in the deeper layer, so this will come towards the upper layer along with the salt, and in this way we see that salinity is more common in those areas where the water table is high. These accumulated salts, they are the soluble salts, and they are the soluble salts of sodium, calcium, magnesium and potassium. So these are the elements which are in the form of soluble salts which will be present in these soils. Anions, that is the negatively charged elements which are found in these soils, they are mostly of chlorides and sulfates, carbonates and bicarbonates. So you please remember what are the anions which are present in these types of soils, and what are the cations which are present in these type of soils. The surface of the saline soil is irregularly covered with white crust of these salts. So these soils are called as the white alkali soils or halomorphic soils, because their surface become covered with the layer of white powdery material, which are actually the salts. So that's why we call these type of soils as the white alkali. Whitish color में वो salt के deposition है ना, तो इसलिए हम इन्हें वाइट अल्कली कहते हैं, या हम उन्हें हेलोमॉर्फिक सॉइल्स भी कहते हैं. जैसे हेलो वर्ड है फॉर फ्रॉम सॉल्ट्स, तो ये क्योंकि उनकी सॉल्टी अपीयरेंस हो जाती है, तो हेलोमॉर्फिक सॉइल्स हम उन्हें कहते हैं. जैसे आपने हेलोफाइट्स भी पढ़ा है, वो प्लांट्स हैं विच ग्रो इन द सेलाइन सॉइल, सो उन्हें हम हेलोफाइट्स कहते हैं. कि हेलो फ्रॉम सॉल्ट, फाइट्स मीन प्लांट्स. तो ये वो प्लांट्स हैं जो कि इन सॉइल ऐसी सॉइल्स में ग्रो कर सकते हैं जिनमें हाई कंसंट्रेशन ऑफ सॉल्ट्स है. Exchangeable ions of calcium and magnesium are dominant in these soils with relatively low amount of adsorbed sodium. ठीक है, so calcium and magnesium, they are dominant in these soils. These are the salts which are dominant in these soils with relatively low amount of adsorbed sodium. So while जो आपकी white alkali soils हैं उनके अंदर ज़्यादा concentration calcium and magnesium की है, और sodium जो कि adsorbed condition में है उसका lesser quantity है. These soils are slightly alkaline. Their pH seldom rising much above 8. ठीक है, एसिडिक साइड पे तो नहीं है, न्यूट्रल भी नहीं है, लेकिन ये थोड़ी बेसिक साइड पे इसकी पीएच है, तो इट इज सेड टू बी स्लाइटली अल्कलाइन. 7 is the neutral pH, so it is slightly more than that, so it is 8. pH is 8. In saline soil, surface often appears dark in color due to accumulation of dissolved organic matter. So the surface appears to be somewhat darkish in color, and you see the humus, it gives the dark color to the soil. The higher the concentration of humus in the soil, the darker will be the color of the soil. Now, depending upon the different properties of the soil, what is their EC, what is their pH, what are the different elements which are present in the soil, or what are the different salts which are present in the soil, we have classified the soils, these saline soils, into 3 categories: saline, saline sodic, and sodic soil. Sodic is from sodium. So first type of the saline soil is saline or white alkali soils. Now we see what are the characteristics of this type of soil. This soil contains concentration of soluble neutral salts in sufficient quantity to interfere with the plant growth. इसके अंदर soluble neutral salts जो हैं वो इतनी concentration में हैं कि वो plant की normal growth को नहीं होने देते. So we say that they interfere with the normal growth of the plant. The EC of these soils will be greater than 4 millimole per centimeter. EC is electrical conductivity. When we were studying the soil properties, we talked about this term EC. So the EC will be more than 4 millimole per centimeter. pH will be below 8.5. Excessive amount of soluble salts of chlorides and sulfates of sodium, calcium, and magnesium can be readily leached out of the soil with no rise in pH. With the help of water which is free of salts, you can remove, which is the leaching down of the salts which I have mentioned, that is the chlorides and sulfates of sodium, जैसे सोडियम सल्फेट, कैल्शियम सल्फेट, मैग्नीशियम सल्फेट वगैरह हो गया, उसको आप रिमूव कर सकते हो लीचिंग डाउन के साथ, कि पानी आप वहाँ पे एक्सेसिवली पानी जो है you apply to those soils, these salts, they will get dissolved in the water. Ultimately water will move downward towards the deeper layer. So along with the water, these salts, they will also be removed from the soil, and there will be no rise in the pH. And but this leaching water should be low in sodium. As we have already said, that the water, you have to take care that water is free of salt, so that के वो उसमें मजीद salinity का बाइस ना बने. Now the second category of saline soils is saline sodic soils. These soils contain concentration of soluble nutrient salts and adsorbed sodium ions. So this is the property, that's why they are said to be the saline sodic, because here the sodium ions, they are present and they are quite toxic to the plant, so they seriously affect most of the plants. pH will be below 8.5. EC is more than 4 millimole per centimeter, and unlike saline soils, leaching of soluble sodic salts will rise pH of saline sodic. Previous case mein we said the pH will not be having any effect, while in this case, when you will remove the soluble sodium salts with the help of leaching, the rise of pH of the saline sodic soils will take place. Soil structure develops an impervious, tight soil crust due to the dispersion of soil colloids by sodium ions. You see, a layer of colloids will be present on the surface of the soil, and this will be in the form of a sheet-like structure which is impervious for any kind of water. So as a result, this will destroy the structure of the soil. Sodium toxicity to the plants is increased at the same time. So number one pe, the soil will become impervious to the water. Secondly, what will happen, the sodium which is present, that will also increase the toxicity to the plant. So this soil is more affecting the growth of the plant as compared to the previous saline soil. The third category of saline soil is the sodic soils. These soils don't contain any great amount of neutral soluble salts. Toxic effects on the plants are largely due to toxicity of sodium as well as hydroxyl ions. So ये वाली जो soil है, इसमें सोडियम की concentration सबसे ज़्यादा है, और हाइड्रोक्सल आयंस की प्रेजेंट में ये जो है ये प्लांट को ज़्यादा अफेक्ट कर रही है. EC is less than 4 millimole. Previous cases में EC was more than 4, but here it is less than 4. pH is above 8.5. Leaching of saline sodic soils will readily change it to sodic soils. These soils are also known as black alkali soils. The surface of the alkali soil is usually discolored due to dispersed humus carried upward by capillary water. So यहाँ के ह्यूमस की कंसंट्रेशन क्योंकि बहुत ज़्यादा है, तो ये सॉइल्स जो हैं आपको डार्क ब्राउनिश इन कलर, या हम इसको ब्लैकिश इन कलर कह सकते हैं, कि दूर से ये आपको ब्लैकिश नजर आती हैं, लेकिन एक्चुअली दे आर डार्क ब्राउनिश इन कलर. सो दैट्स व्हाई वी call them also black alkali soils. और ये coloration क्यों डेवलप हुई? ड्यू टू द ह्यूमस विच इज कैरिड अपवर्ड बाय द कैपिलरी वाटर. Now we see what are the effect of salinity on the growth of the plant. Saline and saline sodic soils, they have detrimental influence on the plant because of high concentration of soluble salts. So salts की high concentration जो है, it will have a very bad effect on the growth of the plant. Shrinkage of the root hairs causing protoplasm, plasmolysis. Cells will collapse as a result of this plasmolysis. You see, when there is high concentration of salts in the soil, whatever the water which is present in the tissues of the roots, it will come out of the root, as a result of which the plasmolysis of the protoplasm of the root cells will take place, and this will result in the death of the root cells. So this will ultimately cause the death of the plant. Nature of the soil, the species of the plants, etc. determine which plant will grow or not. So the nature of the salts, what are the salts which are present in the soil, then what are the species of the plant which can tolerate this concentration of the salt, or the element of the salt which is present in the soil. This will determine that which kind of plants which you can grow in these types of soil. Adverse effect on the physical condition of the soil determine level of salt concentration to be tolerated by plants. So how much the structure of the soil is destroyed, and which are the plants which are able to grow in that particular structure of the soil. This will also determine that which plant is able to tolerate that soil structure and which is not, and it is sensitive and it will not grow over there. So ये आप उसके मुताबिक फिर decide करेंगे कि which plants you can grow in such soils and which plants which you cannot grow in these soils. Sodium carbonates and bicarbonates have caustic influence on the plant tissues. So ये जो सोडियम के different types के salts हैं, sodium carbonate, sodium bicarbonates, they are especially harmful and they are caustic, मतलब they just burn the plant, so they have a very bad effect on the plant growth. So they just burn the plant. So we say that they have a caustic influence on the plant tissues. Permeability of the plant tissues and certain metabolic pathways are toxically influenced. So you see different physiological processes of the plants, that is the movement of different materials, the metabolic pathways, they are all affected due to salt toxicity. Nutrition processes of the plants, they are also affected. So you in short you can say that the physiology of the plant, it is greatly affected by the higher concentrations of different types of salts. Now there are plants growing in the saline habitat. Still we have certain such plants which have adapted themselves to these saline conditions, and they can still grow in these soils which have higher concentration of salts. For example, we call those plants as the halophytes, right? There are certain examples, for example, a triplex, suda, zygophyllum, tamarix, salsola, Artemisia, Kochia, Juncus, Acacia, Alhajae, Beta, Citrus. All these are the plants which can still grow in these saline conditions. So we have still some vegetation which is adapted and which can grow in this type of higher concentrated salt containing soils. Then the crops that tolerate high salt concentration, there are certain crop plants which we grow economically, give us benefit, and we grow them in these soils. They are phaceolus, linum, tomato, lettuce. So all these crop plants, they can also grow in saline soils. Then you see we have besides these plants which we have mentioned, we have certain techniques through which we can make our plants to be modify them in our different labs, tissue culture labs, and in different NIPG and NAAB. These are certain our institutions which are throughout the year busy in developing through genetic engineering such type of plants which can grow in these saline soils. So we also modify genetically our plants and we make them able to grow in these saline soils. Now the management of saline and saline sodic soils, management practices to reclaim salinity. If our soils they have become saline, how we can improve them, how we can make them towards the normal type of soils. So there are three categories in which the soil it become affected, और then how we can reclaim, how we can उसको हम दुरुस्त कैसे कर सकते हैं, दोबारा उसको हम normal soil में कैसे convert कर सकते हैं. So for that purpose there are three methods. Number one is eradication, number two is conversion, and number three is control. One by one we see what are the practices which we do while reclaiming the soil. Number one is eradication. This process is aimed at removing the excessive salts from the soil, making it productive again. If our soils they have become saline, then we try to make them normal again, and that will be that we try to remove the excessive salts from the soil so that we can again make them productive and we can grow our crops on those soils. Measures taken for the purpose involve the application of excessive amount of water. This will result in flushing out excess of the salts from the soils. So you will apply excessive water. Water will dissolve the salts present in the soil within it. So along with the removal of water, the salts will also be flushed out of these soils. Water used for this purpose should be free of silt and salts, and especially the salts of sodium. Toxic sodium carbonates and sodium bicarbonates can be converted into sulfates by treating with gypsum. This is a very common practice in our country, that we, for the treatment of our saline soils, we excessively apply gypsum. And the gypsum, it removes the sodium and sodium bicarbonate from the soil. So in this way our soils they become normal and we can grow the normal plants again in these soils. Okay. Sodium sulfate is soluble and readily leach down. The soil become cultivatable again after this leaching process. Now the second reclamation process which we can undertake, that is the conversion. Measures undertaken involve the converting the toxic salts to non-toxic and soluble form. So conversion means whatever the toxic form of salts is present in our soils, we try to convert those toxic forms into non-toxic forms. So in this way, they are converted from toxic to non-toxic different types of salts. And then afterwards, these are leached down from the soils. Use of gypsum. Gypsum is calcium sulfate. It is very popular, as I was telling you before, that it is a very common practice that gypsum, जिसको हम चूना भी कहते हैं, ठीक है ना, वो हम excessively apply कर देते हैं soils में, और ये फिर बाद में आसानी से leach down भी हो जाता है. So gypsum calcium sulfate is very popular and effective on sodic soils and changing the caustic alkali carbonates into sulfates. Several tons of gypsum is applied per acre Soil should be moist to accelerate the reaction, and gypsum is applied on the surface and then plowed in. When you apply the gypsum, afterwards you plow your field. So in this way, that get mixed in the soil, and the salts, they are exposed to this calcium sulfate, and then they are converted into in different salts of sulfates, and then they are leached down and they are flushed out of the soil. The third measure which we can take is control. That measure involved और aimed at controlling the development of salinity. पहले तो दो ऐसे केसेस थे ना जिसमें कि salinity डेवलप हो गई, और फिर हम उस सॉइल को कन्वर्ट करने की कोशिश कर रहे हैं नॉर्मल सॉइल के अंदर. लेकिन ये जो तीसरा मेयर है उसमें हम ये कोशिश करते हैं कि सैलिनिटी डेवलप ही ना हो हमारे सॉइल के अंदर. सो दिस मेयर इन्वॉल्व और एम्ड एट कंट्रोलिंग द डेवलपमेंट ऑफ सैलिनिटी, कि आप ऐसी कोशिश करें कि सॉल्ट की कंसंट्रेशन आपकी सॉइल्स में बढ़े ही ना. Surface evaporation is checked by covering soil with plastic covers, but they are expensive in Pakistan. So वो जो हम एक लेक्चर में जिक्र कर रहे थे मल्च का, मल्च में आप किसी भी प्लांट के जो वेस्ट मटेरियल है स्ट्रॉ की फॉर्म में वो अपनी फील्ड्स के ऊपर स्प्रेड कर सकते हैं. यानी आपने सॉइल को कवर करना है, तो उससे ये होगा कि एवेपोरेशन जो है वाटर की वो चेक हो जाएगी. एज अ रिजल्ट ये नहीं होगा कि जो कैपिलरी एक्शन से पानी ऊपर आ रहा है और फिर एवेपोरेट हो रहा है, वो प्रोसेस जो है वो रुक जाएगा. So besides this application of cover on the soil or mulch on the soil, other measures which we can take is excess irrigation should be avoided unless used for leaching the salts, right? Then timing of the irrigation is important. Young seedlings are sensitive, so irrigation before and after planting should be done. So you have to manage the timing of irrigation. Use of salt resistant crops, so those soils which are prone to become saline, कि आपको खतरा है कि ये saline हो सकती हैं, तो आप वहां पे you should grow those crops which are resistant to salts. Addition of farm manure to soil reduce alkali content, and less tolerant crops they can be cultivated. So these are the certain control measures which can be adopted in order to save your soil from becoming saline.